Today, ladies and gentlemen, we're going to be doing Unit 3, Notes 2. Okay, and so today we're going to be talking about multiplying monomials. Alright, so yesterday we talked about polynomials. Poly means many, so that means we had many terms. Mono means one, so that means we're only going to have one term. Now, in order to talk about this, we have to talk about a couple rules of exponents. So the first rule of exponents I want to talk about is multiplying like bases, or product of, or sorry, why don't you change that on your note sheet to say multiply like bases. Okay, when you multiply like bases, you're going to add exponents. So if we have something like a to the 6th times a to the 3rd, when you multiply those two together, when you multiply those a's, you need to add the exponents. What you're going to do is you're going to multiply the coefficients. So these both have a coefficient of 1. Well, 1 times 1 is just going to be 1, so we don't need a coefficient. And then we're going to add the little numbers, or the exponents. And 6 plus 3 is going to give us 9. So that gives us a to the 9th. Let's take a look at this next one. So now we're going to talk about taking, oops, not that one. Now we're going to talk about taking a power of a power. So when we take a power of a power, so we're jumping down a little bit, we need to multiply exponents. Okay, so we need to multiply exponents. Here's one thing that students always forget. One thing they always forget is that a coefficient also has an exponent of 1. So that 6 also has an exponent of 1. And this power is being raised those two powers. So that means that 2 needs to be multiplied by each of those powers. So that's going to give us 6 squared, because 1 times 2 is 2, and a to the 6 times 2, which is 12. One last step I would suggest you do would be to simplify out 6 squared, because we can do 6 squared. That's the same as 6 times 6, and that's going to give us 36. And we'll do a lot more practice with this. I just want you guys to get the basic rules of exponents written down. Next, the 0 power. If anything is raised to the power of 0, it is automatically 1. No matter what it is, if it's being raised to the 0 power, it equals 1. Okay, let's go ahead and put this into practice. So let's take these rules of exponents. So take a look at number 1. So first of all, remember, if there's no exponent, the exponent is 1. If there's no other coefficient involved, we're just going to keep that coefficient where it is. And now we need to multiply our x's. X to the first times x squared. So when they both have x's, we can add their exponents when they're being multiplied. So x to the first times x squared, you add those exponents and you get x cubed. Now there's no other y, so that y is going to stay y cubed. And this right here then is your final answer. So next we have negative 3, and then we have x to the first, and I'm going to combine my x's. So I have x to the first times x squared. So when you multiply those two bases, you need to add your exponents. 1 plus 2 is going to give you 3. Then you want to take y squared times y cubed, add those exponents, and you get y to the 5th. Okay, when you multiply things of like bases, you're adding the exponents. Let's take a look at number 3. So for number 3, you see that it's being raised to the 0 power. Well, anything to the 0 power is automatically going to be 1. So number 3 should take you all of 2 seconds. Let's take a look at number 4. Now, in number 4, before we go too complicated, I want to simplify the inside. So I want to take my x's and multiply them together. Remember that that x has an x to the first. So x cubed times x to the first. Well, let's just keep our 6 the same. X cubed times x to the first, add those exponents, and that's going to give you x to the 4th, because we're multiplying them. Then we have y to the first times y to the 4th. We're going to add those exponents, going to give us y to the 5th. Now, all of that is being raised to the 2nd power. Remember what I said when we first learned our rules of exponents, that 6 was being raised to the 1st power as well. So when we take in this power to distribute it, we have to remember that. So we're taking in 2, and we're going to multiply each of those exponents. So 6 to the 1st, so 1 times 2 is 2. X to the 4th, 4 times 2 is 8. Y to the 5th, 5 times 2 is 10. So last thing I want to do to simplify is I want to figure out what 6 squared actually is. So this is something that if you have to use your calculator, go for it. But some of you might know what 6 squared is. That's 6 times 6, which is 36. And then we'll keep the letters the same. Sometimes students ask me what order the letters need to be in, and I usually say just put them in alphabetical order. That's usually the easiest. So now remember that each of these have an exponent of 1. And then we need to take that 4 and distribute it in to each of those exponents. So 2 to the first, 1 times 4 is 4. X to the first, 1 times 4 is 4. Y to the third, 3 times 4 is 12. Last but not least, I want to take 2 to the fourth. That's the same as 2 times 2 times 2 times 2, which is going to give me 16. And then I have x to the fourth, y to the 12th. So then I have this 3, and each one of these, even though it doesn't show it, has an exponent of 1. So when I take it to the third power, I need to make sure I distribute it in. So then I have 3 to the 1 times 3 is 3, x to the 1 times 3 is 3, y to the 1 times 3 is 3. Then I need to simplify that out. 3 to the third is the same as 3 times 3 times 3, which is 27. So I get 27x cubed, y cubed. So that right there is your final answer for number 6. Okay, let's take a look at this monomial. You don't have to write this chart down. It's just there for your reference purposes. So a monomial is a number, a variable, or a product of number or more variables. So a monomial is basically one term. Okay, so monomials that are all real numbers. So if they're all reals, they're called constants. That's what we talked about yesterday. So we can have a thing that's just a number, or we can have a product of a number and variables, like a term that we were using yesterday. So let's take a look at how we're going to simplify these, because we're going to start multiplying some monomials. So how do we know when it's fully simplified? First thing, each base needs to appear exactly once. So please make sure you're writing this down. Okay, so each base needs to appear exactly once. Next, there are no powers of powers, so we don't want to have 2x squared and all of that raised to the third power, because then it isn't fully simplified. Next, all fractions are written in simplest form. So if you have the fraction 4 over 6, that's not completely simplified. You can reduce that fraction. We'll be talking about that more on our next note sheet, but it's something to keep in mind. Okay, so let's take a look at some of these. So now, when you're multiplying monomials, you're going to multiply coefficients, add exponents. So this x to the first, this x to the first right here, that's the same as 1x. So when I multiply the coefficients, I'm going to do 5 times 1, which is going to give me 5. And then with my x's, I'm going to add those exponents, that's 7 and that's 6. I'm going to add the exponents, so 7 plus 6 is going to give me 13. Taking a look at number 8. For number 8, we're going to multiply our coefficients. 4 times a negative 7. 4 times a negative 7 is going to give me a negative 28. Again, multiplying coefficients right now and adding exponents. So now this a has an a to the first on it, even though we can't see it. So then a to the first times a squared, we're going to add those exponents. 1 plus 2 is 3. B to the 6 times b to the third, add those exponents. 6 plus 3 is 9. So that right there is your final answer. Let's take a look at number 9. So for number 9, what I want to do first is I want to simplify down this power of a power. So I'm going to keep 3x y to the fourth as is, and I want to distribute this down. So I have negative 2 to the first, y to the first. And now that's being raised to the 2 powers. So each of those exponents needs to be raised to a power. So I have 3xy to the fourth, and then I have negative 2 squared and y squared. So let's go ahead and simplify that out. Whenever you square a negative number, it is going to become positive. So you have 3x y to the fourth, negative 2 squared is going to be 4, and then we have y squared. So 4 times 3, again, multiplying those coefficients, 4 times 3 is 12. X has nothing to be added to, so it's going to stay the same. Y to the fourth times y squared. We're going to add those exponents, and we get y to the sixth. So then I have 12x y to the sixth. Same thing for number 10. I want to go through and I want to simplify this guy right here first. So I have 2a squared, b squared, and now I'm taking that negative 4, and that's going to be raised to the first power. B is going to be raised to the first power, and then that's squared. So I'm going to take that 2 and distribute it to each one of those exponents. So I have 2a squared, b squared, and then negative 4 to the 1 times 2 is 2, b to the 1 times 2 is 2. So now I'm taking that negative 4, let's rewrite out our first parenthesis, keep that the same. When you take that negative 4 and you square it, it's going to become positive. Okay, and then I'm going to keep that b squared as is. So now I want to combine things. So I'm going to multiply coefficients. I'm going to take 2 times 16. 2 times 16 is 32. A squared is going to stay the same. B squared times b squared, add those exponents, and you get b to the 4th. So this right there is your final answer for that one. Okay, so the biggest thing, multiply coefficients, add exponents. Whenever you take a power of a power, remember that each coefficient has an exponent of 1 that you need to distribute into, and then you multiply the exponents. Let's take a look at some applications. So express the area of a square as a monomial. So the area of a square is length times width. So let's go ahead and we're going to multiply that out. An area is length times width. It'll let me write length there. All right, so we're going to multiply those out. Here's our length, here's our width. So we're going to take 4AB and we're going to multiply it by 4AB. So each of those letters are being raised to the first power. Well, right now we're just multiplying monomials. So we can take 4 times 4 and that will give us 16. A to the first times a to the first, add those exponents, you get a squared. B to the first times b to the first, add those exponents, and you get b squared. This is as far as it can be simplified. The a's and the b's cannot be combined anymore because they have different bases. Bases meaning the letters themselves. Okay. Next, let's go ahead and let's take a look at this triangle here. So for this triangle, we're going to do 1/2, and then we're going to multiply the base. Just for your side notes, to do an area of a triangle, it's 1/2 base times height. So we're going to take the base, which is 3 a to the 4th b, and then the height, 4a b to the 5th. So now we need to multiply our coefficients. So 1/2 is kind of like having a coefficient, and you can also look at 1/2 as dividing by 2. So I have 1/2 times 3 times 4. Well, 3 times 4 is 12. Divided by 2 is going to give you 6. A to the 4th times a to the 1st is going to give us a to the 5th. Then b to the 4th times b to the 5th, add those exponents, and that's going to give you b to the 6th. So this would be the area of that triangle written out as a monomial. So that concludes your note video today. Feel free to show me your note sheet once you're done. Thanks for listening.